Hello, everybody, again, and welcome to our next webinar for openQRM Enterprise. I am Candy Picono, CEO of openQRM Enterprise. The technical side, again, today is going to be taken over by Matt Eschenburg, our founder and senior technical advisor. Today's webinar is going to be network deployment with openQRM. We're going to go through a quick presentation again, and of course have a live demo. The agenda today, we're going to have a quick look at the architecture, quick look at what network deployment is in openQRM exactly, storage, we're going to have a look at the operating systems, and of course migration, high availability. I'm going to finish off with a live demo for network deployment, and I'll be happy to hand over to Matt now.
Hello, everybody. Thank you for your time. This is Matt Rechenberg from the openQRM Enterprise company. Today, we are going to talk about network deployment. For all who are not yet fully familiar with openQRM and what it can do for you and how it can automate your IT environment, we take a quick look at the openQRM agenda of openQRM architecture. So the main part of openQRM is automation. What we have done for that is to have several abstraction layers built into openQRM, into the openQRM model, to unify, for example, different types of virtualization technologies and also physical system deployment. So you see it on the right side, we have KVM, VMware, Citrix, Xen Server, Xen, Docker is supported, and several more. And also physical system deployment is one of the focus for openQRM. On the other hand, we also have abstraction layer for storage. That means, in general, any type of storage is fully supported by openQRM, can be attached to for having local virtual machines on it, or there's also a native storage integration which is provided by the openQRM Enterprise itself for iSCSI, NAS-based server, and also co-RAID server with the AOE protocol, which consists of a storage plugin in openQRM to make the specific technology available through the storage abstraction layer. So the main point where we talk about today is a combination of both the resource abstraction layer and the storage abstraction layer. There's also another abstraction, which is the deployment, which means how your system is actually going to be installed automatically, or image-based deployed, or if it's a virtual machine where we need to provision the image. All these types, there are several different types supported in openQRM. And the reason why we are doing this is we don't want to force you to have a specific way of how we think it's the best way to deploy a virtual machine or a physical system, but you can choose what technologies fits best to your preferences and select them, and openQRM automatically combines them. So any type of virtual machine is supported with any type of storage. This so far to the main architecture, and I will now go specifically down the network deployment type in openQRM, which is implemented by several different technologies. In general, for network boot, we can either use physical systems and just set the BIOS to PXE boot, or we can use any virtualization plugin for network deployment in openQRM, which is like basically KVM, VMware ESX, everything which is not a container, but a real virtual machine can be used for as the resource for network deployment. The other part is the storage part. So any of the storage plugins available there can be used for network deployment. For physical systems, there's also a mechanism available which auto-discovers new servers in your network. So simply turn them on, and they will discovered by openQRM and booted into in a state what we call idle, which means it's available for further management through openQRM, but it's not yet used for any specific purpose. So the purpose you can then decide from openQRM, and from this idle state, it will then go to provisioning and inactive. So for non-physical system, which means virtual machine deployment. There are several resource providers in openQRM like Citrix, KVM, VMware, ASICSI, or Xen, which provides a server resource object, which then can be used for the further provisioning workflow. The storage side of this network deployment type is implemented by several different technologies. As I already mentioned, there's AOE-Storage available, iSCSI, NAS-based, NFS-Storage, and there's always the option to put like a logical volume manager underneath it for more efficient image and volume management. So this provides then snapshotting and cloning functionalities, which are available through the logical volume manager. There's one specific storage part for a network deployment, which is TMPFS deployment, or TMPFS-Storage basically. I will skip this here and go into further details later. It's something very cool, for example, for virtual machine host deployment. As I said, any type of virtual machine, any type of physical machine can be deployed with any type of storage plugin. So this is fully any combination is supported, and the combination is selected by your preferences, basically. Okay, why would we want to do this? It's always a good question, of course. This deployment type is ultra flexible. It means all the volume actions, for example, they are not like networked, bridged through the host or to on the server itself, but it can happen directly on the storage, on your backend storage, where the system is booting directly from a volume of a backend storage. So this means there's a complete separation between the actual system, the virtual machine or the physical server which is going to be deployed, and the storage system. And this makes environments a lot less complex. For example, for virtual machine deployment, regular things are, yeah, we need to attach a storage to the host so the host can save its images on the storage. For this deployment type, it's not needed at all, because the storage is completely separated and does not need to be attached to any of the virtual machine hosts. This means a less complex backend system, and lower complexity means increased robustness and advanced high availability, where high availability is also a good point. I'm come to this also a few slides later. Also important, like as I said, backups for which using cloning or snapshotting actions are now possible directly on the backend storage, which means there's less I/O in general, and there's less data which needs to be moved through the network, for example. Network booted virtual machines or physical systems, they are just using the regular init system provided by operating system, by Linux operating system, and it's very, very similar to local boot, but high availability is a lot easier. So because there is no local storage on the system itself, and the root file system is already a remote, the openQRM can understand when, for example, a virtual machine is crashed or a host is crashed with several virtual machines on it, and simply restart the existing operating system images on a different host. That means also high availability becomes a lot less complex and a lot more robust. So there's also one cool feature about high availability on the next slide, but before that I go into details for in-memory OS deployment. For example, for virtual machine hosts, if they are not need to be connected to any storage, they basically do not store any data which is connected to the virtual machines at all. This happens all on the storage layer. So what we can do with this deployment type, with TMPFS deployment, is we can put the operating system inside a TMPFS root file system on the system, which means it's directly in memory, and it will boot from memory. It means those systems can be even diskless, and since disks are local disks are the most thing which are going corrupt at some time, at some point of time, this whole point of possible failure can be removed from your virtual machine host at all. So they can be simply non or diskless or completely diskless virtual machine host physical servers, which are like booting an operating system which is put in RAM during the boot stage. Further on, I would like to also tell a very cool feature about migration high availability. What we can do with openQRM then, while everything like storage is abstracted and also virtual machine is abstracted, like physical or virtual machine is abstracted at one point. There's support for any type of migration from virtual to physical, from physical to virtual machines, and also from virtual machine types A to virtual machine type B. This happens since the PXE stage is completely standardized either for physical systems or virtual machines. This migration is completely transparent, and there's not any modification to the underlying operating system needed to support this type of migration. This specific very cool feature we support, we call it N-to-1 failover, because what we can do, we can support or provide high availability for a huge group or for a huge number of physical machines by just one single standby. How this can work? It's simple. For this type of high availability, we can fail over a physical machine in case of a crash or an error transparently into a virtual machine. So there's no change on the operating system or on the data of the image itself. It will be just the same image booted, not on a physical machine, but on a virtual machine of your choice. So in that case, or for example, one hypervisor would be sufficient for a group of physical servers to provide 100% or like 99% high availability. Okay, let's look at it a little bit more visual, how, for example, a network deployment environment looks for KVM. There is any type of storage on the upper left. It can be NAS-based or it can be block file-based, like iSCSI-Storage or AOE-Storage. And they just need to be on a network, which is normally a dedicated storage or management network, which is connected to the hosts. But as I said, the storage objects, storage server, and the virtual machine host in this scenario are completely separated. So the volumes of the storage actually do not need to be mounted or attached to any of the virtual machine hosts. The virtual machine host itself, several systems with bridges or network bridges are configured so that they can be attached to different public networks for the KVM virtual machines, and an openQRM server or an openQRM HA cluster who manage the storage and the physical systems. Or better to say, in this example, the virtual machines on the physical systems. But also for this kind of scenario, the regular way for our customers and users is that the virtual machine hosts are actually deployed via network deployment, also from openQRM directly from the storage. So actually the whole environment, the host itself and the virtual machine can be put completely on the storage without even having directly access to it. Okay, how this works down the detail for the network boot, it's on the next slide here. So on the left we see a physical system or a virtual machine which is set to network boot. On the right side, there's the openQRM server, and underneath there is a storage and one of the images or volumes of the storage. And I will explain now what exactly happens when a system is going to be deployed via network deployment. So the first thing will be the system will try its first network card and send out a PXE request, which is a broadcast to the next DHCPD server, which is running on openQRM with the DHCP plugin. openQRM answers this request with an IP address, a kernel file, an init file, which is completely modular and pulls further configuration information from openQRM during the initial boot stage of the init. So this happens all before the actually operating system image, also on your local installed physical or virtual system, very early in the kernel boot phase. So openQRM then authenticates it, goes through the storage through an API of the storage, and authenticates the image for the resource. That means it makes sure only the specified resource, which is just booting, is able to connect and access a specific root file system, a volume with the root file system on the storage server. So while it's booting up, it connects to this volume and uses it as its root file system. That means actually the system do not need to have access to any local disk, so they can be run completely diskless, for example, like the virtual machines, for example, like the network deployed virtual machines. Okay, next thing on our the webinar is the live demonstration. I will now go over the workflow of how to create and configure a virtual machine, which will boot directly from an iSCSI target, and we will also use an empty volume. We make a new volume for that, which is going to be automatically deployed with an operating system during the boot up stage. So actually, we'll boot an empty iSCSI volume. During the boot up, it will be filled with the root file system, and then the system will boot up from the iSCSI image or iSCSI target. We'll see this and use this as the local disk. Okay, here we are with openQRM. This is the main data center dashboard. You see there are several things which were already pre-configured, and we will today, as mentioned, now provision a virtual machine completely network deployed from an iSCSI storage server. So this is the server overview. There are several servers already existing here, but we want to create a new server. It should be named webinar. Okay. This wizard for creating a new server will be always the same workflow for any type of physical or virtual machine deployment. So it's very generic and uses all the abstraction layers mentioned before. So we can either use existing resource, which are all in use currently. We want to create a new resource anyway. It should be KVM network deployment. No, I don't want to translate this page. No, thanks. Okay. This brings us to the host selection. If you have more KVM hosts, for example, they will be listed here. For this webinar, we just have one openQRM, one virtualization host here, and we want to create a new network virtual machine on it. So we can set several configuration parameters here, like different network cards, MAC addresses, and so on. We want to boot from the network. We also want to have it with VNC access. And this will create the virtual machine, which is already like network booting automatically into openQRM then. We will see it later. We'll see it as an idle resource then. but the wizard automatically brings us back to this resource selection, and the resource we just created is now available. So we select it and go on with it. Next time would be we select a volume, an image with a root file system or on it, or with a deployment mechanism attached. We have several here available, but we want to create a new image. This should be an LVM iSCSI image, which means it's accessible through the iSCSI protocol, which is basically SCSI over IP. And it provides a block file, and it has LVM underneath, so we can also very easily snapshot and clone it in a very efficient way. We select the storage server for it, yes, this one. This brings us to the logical volume overview, the volume groups here. There's one volume group available, which we select for the root file system. Then we want to create a new logical volume for this. This should be named webinar. Let's make it 2 GB big, just for the small root file system. This is should be sufficient. This action now will create on the storage server a logical volume, which is then accessible through iSCSI protocol. It brings us back to the wizard, and we have the image we just created pre-selected. Yes, we want to edit the image after that, after selecting it. So we can also like override a predefined root password by an eventual automatic installation or so. There are several ways to deploy this system now, which is actually now an empty volume on the iSCSI storage server. And we want to deploy it from a NAS server and from this specific Debian 7 KVM net image. So actually, the root file system will come from this image, which is stored in a NAS. It will be populated through boot up through the iSCSI target after it's connected. And the system will then continue boot up on the iSCSI target as with a regular init mechanism, as you are known from local installed systems. We go on. The next thing is we could choose the kernel for this. I would like to have the default kernel installed for openQRM. This is fits for that. And this is the last step of the wizard. Basically, the resulting object, what we created, is this webinar server object. It includes a network booted virtual machine, which is here, the idle resource. It includes the webinar image, and it also has, for the image, configured that it will be populated during the boot up stage. So that's all. We simply start this server object, which will run the whole provisioning workflow fully automatically for us, and the result will be like a ready server with all pre-configuration set, with operating system on it, fully deployed, with no manually interaction needed anymore. So actually we want to see what's going on. So we use NoVNC, the NoVNC integration to openQRM with for yeah, we want to allow pop-ups, yes. Just a moment, please. What's that? Oh, excuse me. Let me just have a quick check. It's the browser which is, for some reason, blocks the SSL certificate. Not sure about this. Just a moment. Let's see. Here we go. So actually, the system is already started. We see it has connected during boot up stage the webinar volume, iSCSI volume from our storage server. It's actually connected as SDA. And since we have installation from NFS enabled, it's now installing from the Debian 7 KVM net volume to populate the root file system, and we will see very soon booting further up the stage. So please give us some short minutes while the system is going to be automatically deployed. It will soon continue further boot up, and then we can access it, and I can show you that the system, the virtual machine operating system, which actually has no idea that it's booted from a remote network file system or network attached block device, basically. So please stand by. It's still taking some short time. It's a small image, but it will be like fully deployed in very short time. This is also like the populating process for this volume, which is the mechanism is called install from NFS or install from NES. Is also a one-time action, of course. So this happens only once you want to populate a new created empty volume, an empty iSCSI or NFS volume on your storage server. This can be done directly during the boot up stage. So actually, it's one step of the deployment. You see, it's now further booting on. It has done the install from NFS phase, finished, continue boot up, and it will now jump into the iSCSI system just as a regular local installed system for further starting of the init services. This is already the openQRM client, which was started automatically. You see, everything is being set now. The webinar server is fully ready, deployed now. I can just log in from here. When we look at the disks, actually, the system is booted, has its root file system on /dev/SDA, and this isn't actually a local disk, but it's the remotely attached iSCSI disk. I can also show you, I would like to show you now again the complete boot up of the system, so you can see actually what happens on the technical side for network booting the system. For that, we simply stop the system again. This will reset basically the automatic installation which is attached to the virtual machine. Okay, so we'll take a small moment until the system is basically rebooted and into the available idle state again. It's still coming up. We'll make another window with the VNC open soon, so that we can actually see the initial boot phase of the system. Okay, it's now in available idle state again, and we can now restart it. It actually will not go through the installation phase again, so the boot up will be a lot faster. And I hope I can show it to you from the first stages on. Just a second. Okay, here we go. Here's the PXE request. It boots the default kernel now from the openQRM server. This is already inside the automatic hardware detection for a network card inside the openQRM custom NetID, which is very modular. It now has connected to openQRM to get further configuration parameters, and it's now importing the full kernel files for further hardware detection. So any kind of hardware is fully supported and detected. Here it connects to the iSCSI discovery. You see the webinar volume is connected, and it skips all the installation phase because there is already root file system on it, and we jump now directly into regulated. Was a bit fast, but that's how it works. You see, the system is coming up with within no time, and you could see that it's not booting from any local virtual machine disk, but it's really booting from a remote storage. This system, to move this system to a physical machine, it's like just a few mouse clicks and reconfiguration openQRM with no changes on the actually operating system image. Cool. I'm done so far. I hope you enjoyed this webinar, and especially the very cool feature of our network deployment in openQRM. Hope you see you next time, and have a nice day and a great start into the weekend. Bye-bye.